If you can't find a Raspberry Pi at the moment to use with your 3D printer, then these just might be what you need. Today we test the Bigtreetech Pi Substitute CB1 with a Pi 4 adapter for Octoprint and the Manta mainboards with embedded CB1 for Klipper. I've had a few requests to test the Raspberry Pi substitutes that are starting to hit the market. So when Bigtreetech offered me the CB1 with Pi adapter, as well as the Manta mainboards designed for Klipper, I said yes. They've sent me these products free of charge in accordance with my review policy. Let's jump in by looking at how Raspberry Pis are used with 3D printers and why that has become problematic. Much of the focus for this video is on a Bigtreetech replacement for the Raspberry Pi. In case you didn't know, a Raspberry Pi is a single board computer about the size of a credit card. And yes, you can plug in a mouse, a keyboard and a monitor and use a Linux operating system. Raspberry Pis are compact, power efficient and inexpensive, and that makes them useful for a range of projects. In 3D printing, the most common use for a Pi is in the back of a printer, where it can talk to the 3D printer and provide us a nice wireless web interface. We can control the 3D printer remotely, as well as monitor printing progress. Another way Raspberry Pis are used with 3D printing is to run Klipper firmware. In the case of Klipper, it occupies both the Raspberry Pi and the original 3D printer mainboard. Just like Octoprint, we'll get the benefits of wireless control with a camera feed, and Klipper also has the advantage that the grunt from the Pi allows for precise stepper control and, if you like, some really fast printing. But here's the problem. Here's all of my spare Raspberry Pis and they're all older models. And that's because when you try to buy one, most likely you'll find that it's sold out. And it's been like this for some time, with Raspberry Pis quite difficult to get all around the world. Fortunately, Bigtreetech and others are offering an alternative. And that brings us to the Bigtreetech CB1 or Control Board 1. Here it is in the flesh, and as you can see, it's smaller than a normal Raspberry Pi 4B. And that's because its connectors and form factor is designed to match a Raspberry Pi product known as the Compute Module 4, which is also very hard to buy. What both the CB1 and CM4 do is split the processor, memory and other parts of the board from the input-output ports. Think of it like buying the microcontroller by itself instead of a whole Arduino board, because you're intending to create a custom PCB with the exact input-output you need for your application. So the Bigtreetech CB1 is meant to be a substitute for a Raspberry Pi CM4, but we can also get a Bigtreetech Pi 4B adapter. And this is shaped just like a Raspberry Pi 4B, but missing the chips that are present on the CB1. The idea is that the CB1 clips into the 4B adapter, and now we have a physical equivalent of a Raspberry Pi 4B. So can we do a straight substitution for the CB1 in this adapter for an actual Raspberry Pi? Let's find out. Here is a project driven by a Raspberry Pi 3B that I previously made on the channel in time for Halloween. I wanted to see if the Bigtreetech substitute could power such projects without any modification. If I was switching to another Raspberry Pi, swapping would simply be a matter of transferring the SD card from one to another, and then plugging any wiring into the GPIO pins in the same location. However, after powering up the Bigtreetech option, I found that no matter how long I waited, the eyes just wouldn't come to life. Next up, I tried the same test on an Octoprint installation, removing the SD card from a Raspberry Pi 3B, inserting it into the Bigtreetech CB1, connecting it to the 3D printer's mainboard, and powering up the CB1 as well as the printer. But once again, this transfer failed. I also substituted the CB1 and Pi 4 adapter with a Pi 4B used in a Klipper installation, but just like before, it failed to boot and appear on the network. So clearly the CB1 is different enough to not work in this way. Firstly, the processor. A Raspberry Pi 4B has a quad-core Cortex A72, whereas the CB1 has a quad-core Cortex A53. If it's your thing, you can examine the technical differences between the two. I'm not sure how reliable a benchmarking site is for a 3D printing application, but as we can see, the A72 easily outscores the A53 from the CB1. But perhaps the easiest comparison to make is that the older Raspberry Pi Model 3B has an equivalent spec processor to the CB1. The Raspberry Pi 4B is also available from 1GB through to 8GB, but the CB1 is limited to 1GB of RAM only. So grunt-wise, the CB1 is not the same as a Raspberry Pi 4B, but perhaps the main reason we can't switch between the CB1 and the actual Raspberry Pi is that with the change of hardware, the CB1 has a different kernel, an integral layer in a device such as this, and making a straight swap between the two incompatible. So what's the process for using a CB1 instead of a Raspberry Pi? Rather than starting with a Raspberry Pi SD card image, we need one for the CB1 from the Bigtreetech GitHub. We can come down to latest system image, and then we're presented with a minimal version, which is based on the Debian Linux operating system, and then there's an image with Klipper, Moonraker mainsail and Klipper screen, which we'll test later on. We're going to scroll down and click to download the minimal kernel file. To install this operating system onto the CB1, we're going to use the official Raspberry Pi imager, and the link for this page to download it is in the video description. The recommended size for the micro SD card is 16 GB. To flash our image, we're going to choose our operating system, scroll down, and select custom image from our computer. We'll then select the image file that we just downloaded and select our drive. Double check you've selected the right SD card, because if you accidentally select an external hard drive, it will overwrite the contents. We can ignore the custom options and click on write. When it's done, we'll be prompted that the process is finished, and we should ignore any messages asking us to format our newly flashed SD card. There should be one Windows accessible partition on the SD card, and in that we'll find a file called system.cfg. If we edit this in something like Notepad++, we'll see a place for us to enter our Wi-Fi network name and Wi-Fi password, and once we've saved our details, we can close the file and eject the SD card and insert it into the Pi 4B adapter, which has the CB1 inserted into it. Here I also chose to plug in a screen, mouse and keyboard, before powering everything up with a power bank. After a couple of minutes, I arrived on a terminal and I was able to log in using the default details, BQ for the username and BQ for the password. I was also able to use the same details to connect via SSH using PuTTY. I then found a straightforward guide on installing a desktop environment and followed it to install GNOME. This was very straightforward, and when the automated process had finished, the CB1 rebooted to a Debian desktop environment. Ignore the discoloration on the screen because I haven't configured that properly, and observe that the operating system is working just as if it was installed on a Raspberry Pi. So that's one generic use, but what's it like to set up for Octoprint? To start this process, I reflash the minimal image back to the SD card. Normally when we install Octoprint on a Raspberry Pi, we use the Octopi SD card image, which we download and flash with the Raspberry Pi imager as we saw earlier. Except we can't use that, and therefore on the instructions page we're going to have to scroll way down until we get to the installing manually section. We'll click through to a link in the forum with all the step-by-step instructions, and then it's a matter of copying and pasting the commands one at a time into the PuTTY terminal and running them. If you don't know what PuTTY is or how to use it, I have a tutorial linked in the description. The instructions are thorough, and if you're able to copy and paste, you will be able to follow them. The only downside is it's a lot more laborious than flashing a pre-made image, and it will take a lot more time. The only change comes when you're setting up the users for Octoprint. Instead of using the Pi username, you need to change it to BQ. If you try and run this command with the Pi user, you'll get an error rightly saying that that user doesn't exist. Eventually, I completed the steps and everything was done, so I rebooted, entered the IP address into my browser, and was met with the setup wizard for Octoprint. Compared to the pre-made SD card image, there's a couple of extra setup steps, but ultimately it's a working version of Octoprint, and I had no trouble connecting to a 3D printer and controlling it manually. Because the CB1's kernel is different to that of a Raspberry Pi, we can't use the pre-configured SD card images that we normally would, but with some manual effort we can arrive at the same result. Now let's look at a Klipper installation with mainboards that are designed to embed the CB1. These two are Bigtreetech mainboards called the Manta M4P and the Manta M8P. Named so because the M4P has 4-stepper motor driver outputs with 8 for the M8P. You'll notice that as well as the usual 3D printer inputs and outputs, you'll see some parts that are familiar to a Raspberry Pi, such as HDMI, Ethernet, and ribbon connectors for displays, as well as the 40-pin GPIO header. Comparing the M8P and the M4P, we can see that the processor is slightly different on the M8P, but most of the changes revolve around input-output, with the M8P having additional ports for heaters, additional ports for fans, and of course double the amount of stepper motor outputs. It also has additional options for thermistors and thermocouples. The M8P also has more beefier power terminals and is better suited for a more high-end 3D printer. What both of these boards have in common is a socket to install either a Raspberry Pi CM4 or a Bigtreetech CB1. Once we've installed this onto the mainboard, we end up with a very Klipper specialized mainboard because it has an embedded Raspberry Pi, or in this case the CB1 substitute. This differs from most Klipper installations that add a separate Raspberry Pi to the existing 3D printer's mainboard. So what's it like to install Klipper on the CB1 and these Manta mainboards? There's a GitHub repository for both the M4P as well as the M8P, and each contains a user manual with fairly detailed instructions on how to set up and configure the mainboard as well as the CB1 or CM4 Raspberry Pi. We could start again with the minimal image and then run various scripts to install the elements of Klipper, but instead I returned to the GitHub page for the CB1 and this time downloaded the SD card image with the Klipper elements already in place. I followed the same procedure as before to flash this image to my SD card, entered my Wi-Fi details into the system config as before, kept it in the Raspberry Pi 4B adapter for now, booted it up, and entered the IP address into my browser where I was met with the mainsail interface, albeit with expected errors because the printer configuration file at this point is empty. That's to be expected on a new install and everything else seems to be working as it should. I've previously made some detailed step-by-step guides to installing Klipper on various 3D printers, so for this guide I'll focus on the things specific to this mainboard. In those guides, currently we'd be at step 2, having installed Klipper and a web UI on the Raspberry Pi, and now we move on to step 3, installing Klipper onto the mainboard's MCU. From this point onwards, we need the CB1 taken out of the Pi 4 adapter board and placed into our mainboard. We also need to insert the SD card from the CB1 into the mainboard slot. At this stage, I'm powering the board by 5 volts, and for that to work, I need to insert a jumper on the J8 connection. Once this is done, everything boots up, ready to continue. Doing this means connecting by SSH to the Pi, running the make menu config command as usual, and then copying all of the settings from the manual. After that's done and double checked, we can press Q to quit, followed by yes to save. Finally, we type make to compile the firmware for our mainboard. Rather than update using an SD card, we're going to try and update directly as the two devices are connected. We start by copying the command to list the serial devices, and when we run that command, the mainboard will reply and provide us its serial ID. We then copy the make flash device line up to by-id/. We paste that line into PuTTY and then paste in our serial ID from earlier, delete the gap and hit enter to run the command. If you leave the gap in, the process won't work. If it is working, you'll see an animated download bar and afterwards there might be an error, but according to the manual this is normal, and as long as it says download successful, the process worked. For now we're finished with PuTTY, so we can connect back to Klipper using our browser. We'll come to machine and sort out this missing configuration file. It's actually already there, but as you can see, it's pointing to a file that doesn't exist, so I'm going to delete that line, and there's nothing else there. Matching our previous guides, we're up to step 4, which is setting up the configuration file for our printer. If we go to the GitHub page for either of these mainboards and come into the firmware Klipper folder, we'll find some example configuration files with all of the correct pins in place. So I'm going to copy that, come into the blank configuration file for this install and paste it all in. The first thing to do is to fix the name of the serial port, and we'll need PuTTY one last time for that. We use the same setting as earlier where we list the serial devices by ID. We'll copy whatever comes up and then paste it after by-id/, replacing whatever generic value was there. I'm going to save and restart and make sure that everything connects. And everything did until we received an error complaining about min temperature, which makes sense because we don't have a thermistor connected. To fine tune everything, you can try and find an example configuration file for your 3D printer. For instance, this board is going into an end of 5 for me, so that's what I'll open up, and I'll copy and paste as I need to, things like rotation distance, maximum positions for each axis, and thermistor values. Of course, you want to ignore the pin values in this file because they're for the factory Creality board, and we've already got the correct ones for the board we're using. If you're switching from another firmware like Marlin, you can always take settings from in there, and in my case I took bits and bobs from other printers that were already running Klipper. With most of my config in place, it was time for the physical install. There are some 3D files on the GitHub for mounting in a Voron 0, as well as a step file of the board for designing around. In my case, I just needed the 2D diagram with all of the mounting hole dimensions, and I used this to make a variation of my Ender 5 electronics case with mounting holes to match. While that was printing, I decided to prep the main board with all of the jumpers. I firstly removed the temporary jumper to power the board from 5 volts, and then I consulted the manual, which does a good job of telling you where to put jumpers for various stepper motor drivers, as well as where you need jumpers for high voltage steppers or using sensorless homing. I'm reusing 2209s that were previously in the printer, so I set up the jumpers for UART mode, matched up the pin pattern and inserted the 2209s into the main board. The rest of the jumpers were already in the right position for me, as I'm using 24 volts and no sensorless homing. With this done, I could start the process of unplugging everything from the old mainboard and SKR2 and plugging it into the new Manta mainboard. Once this was done, I still needed some cable management, but functionally everything was finished and I could turn the printer on. The early calibration is something I've covered in plenty of detail before, basically going through the Klipper docs, making sure there's no errors, that the correct temperatures are being read, checking each axis travels in the right direction, and then completing things like PID auto-tune. I've also covered things like interfaces before, and I followed the contents of that video to get the factory Ender 5 LCD and control nub working with Klipper. Previously, I fitted a Euclid docking ABL system to this printer, and I had no trouble adapting the docking sequences to deploy and stow this probe. I was able to get this Ender 5 running on Klipper using the CB1 Pi substitute and Manta M4P board without any particular trouble. I used the wrong slicer profile here and I haven't done any calibration yet, but those are going to be the same as any other Klipper install. I've tried a few things, I've got the printer working, so what are my overall impressions? Despite physically matching a Raspberry Pi 4B, the CB1 and Pi 4 adapter is closer to a Pi 3B in performance. That means that this Pi substitute is plenty good to run Octoprint, however at this stage it's much more inconvenient to do so because all of the components need to be installed manually via SSH. In the future, maybe an Octopi image will be available for the CB1 and setup will be just as easy as an official Raspberry Pi. When it came to setting up Klipper, I found the pre-prepared SD card image really good. I was up and running with Mainsail and Klipper without any extra difficulty over a Raspberry Pi install. Some of the components needed updating, but this process works exactly like a Raspberry Pi with a single click in Mainsail to update them to the latest build. And I only needed to change a single line in the configuration for the webcam before it worked just like you would hope in the web UI. I think the CB1 documentation needs more to explain the difference between the kernels and various SD card images, but the user manual for the two Manta mainboards are quite good, and I was able to find everything I wanted quite quickly and easily. If you want a compact way to run Klipper, I think the combination of the CB1 and either of the Manta mainboards is very efficient and offers a pretty seamless setup experience. However, manufacturers such as RatRig that offer pre-compiled RatOS for a range of boards will need to add a custom SD card image to suit the CB1 kernel to make the CB1 and Manta boards a viable option for their specific 3D printers. But in the end, it probably comes down most to price and availability. If you can find a Raspberry Pi 4 in stock, the price will be ludicrous. Whereas the CB1 and adapter is $40 US, the CB1 with M4P board $62, and the CB1 with Manta M8P board for $78. Raspberry Pis work so well with 3D printers, so it's become frustrating that they're now hard to get. I'm just happy that there are viable alternatives, and I will be testing more of them in the future. Let me know in the comments section, do you think this is a suitable Pi alternative, and will you be considering giving it a go? Thank you so much for watching, and until next time, happy 3D printing.
G'day, it's Michael again. If you like the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.